Click the bell icon to get latest videos from Ekeeda.
Hello friends, welcome back to the subject of Machine Design 1. Now we are going to do the design safety check for the selected screw. In the last lecture we have derived the notations for it and we have found out different values of its dimensions. So there are two aspects which we need to consider: torsion and compression, because the screw, the power screw, is going to fail under only these two conditions, the torsion and the compression, and that's why we have to consider both of them. So as far as the torsion is concerned, we know that shear stress is going to be induced, so we need to find out the shear stress for the component. We know that there is a standard formula for shear stress which has actually derived from the torsion equation, which says that torsion is equal to into shear stress, and that's why using this expression we are going to find out shear stress. So let us substitute the values. The torsion T1 value we already know. As we have found out this value, we are going to use the same value. And the core diameter that we already have, upon calculating we will get the value. So this is what the shear stress is going to be induced. Let's move ahead with the compressive stress. The formula is quite straightforward. And after calculation we will get the value 48.95 Newton per millimeter square. So these are the two prominent stresses which are induced in the given screw. So with this we are going to check against the safety. Now there is another aspect also. The screw may fail under the direct compression as well as the bending also. So this different combination also we need to consider, and for that we have used the bending equation. So we have to find out the bending stress accordingly. We have already found out the value of second torque, which is because of the bending, and it comes out to be this value which we are going to use. The value is 57 into 10 raised to 6. Upon solving this, we'll get the value. So that is what the bending stress going to be induced in this particular power screw. Hence, let's move ahead with the maximum torsion. Now guys, we need to understand that the screw may fail under the combined loading, where we have to consider the maximum principal stress. So that is one aspect, and it may fail under the maximum shear stress. That is the second aspect. So we may find out both of them and then we can compare the values, and accordingly we can find out the answers. But since the torsion itself can be a criteria of failure, we are going to consider the torsion only. So it comes out to be the value of shear stress upon evaluating tau max will be, this is what the value of maximum shear stress that can be sustained by this particular power screw. Now we have to cross verify this particular thing with the available value. We know that it's a kind of ductile material, and we know that the shear strength is exactly half the yield strength, the allowable yield strength. So the allowable value we already have found out is 80. Now this is the allowable value of shear strength or shear stress that can be included in the given power screw, and this is the value of shear stress which will be induced inside the given power screw. So after comparison we know that allowable value is greater than the induced value, and hence we can say that this particular power screw is safe. So this is the one aspect we have seen where the power screw is going to be safe and it will not break under the combined loading of compression, bending as well as the shear. In the next lecture, in the next video, we are going to see whether it is safe in buckling also or not, and thereafter we will go for the design of remaining parameters. Thank you so much for watching this video. If you like this video, please subscribe to Ekeeda.